Assalamualaikum and hi everybody. So for topic 3, applications of differentiation and integration in economic and business. In this topic, there are 3 subtopics. So the first one, price, revenue, cost and profit function. The second subtopic is maximum revenue, minimum cost and maximum profit. And the third subtopic is consumer surplus and producer surplus. So in this lecture 1 of 4, there are 2 learning outcomes. So the first one is introduction to price, revenue, cost and profit function. And the second learning outcome is to determine average revenue and average cost. 3.1a, Introduction to Price, Revenue, Cost and Profit Function. So let us see what is price. So price, denoted as P of X, is the price or demand function, which is the unit price offered for X unit of product demanded, where revenue, R of X, represent the total revenue for selling X unit of product. Total revenue is given by price times quantity. So this is the formula for revenue. And what is cost? So let's see. If X is the number of unit of a product produced in some times interval, then C of X is the cost function, which is the total cost to produce X unit of product. So the total cost consists of the fixed cost and variable cost. So this is the formula for cost function, which is fixed cost plus the variable cost. The fixed cost is the cost incurred when no unit of product is produced. We can say C of 0 is the fixed cost. Now let us see what is the profit. So a profit function is derived from the difference between the total revenue function Rx and total cost function Cx, and denoted as pi of x. So total profit equal to total revenue minus total cost. So this is the formula for profit function. For 3.1b, determine average revenue and average cost. So what is average revenue? The average revenue is referred to as the revenue that is earned per unit of output. In other words, it is the revenue that is obtained by the seller on selling each unit of the commodity. Average revenue of a business is obtained by dividing the total revenue with the total output. Okay, so we have R bar equal to Rx over X. The average cost is the cost to produce 1 unit of the product. So C bar, the average cost, is given by C of X divided by X. Let us look at example number 1. Given the cost function C of X equal to 2x cubed minus 3x squared minus 12x. Find the average cost function. So the average cost function C bar of X is given by Cx divided by X. So Cx is 2x cubed minus 3x squared minus 12x divided by x. So we factorize, we get x times 2x squared minus 3x minus 12 over x. So simplify, then C bar of x, the average cost function, will be equal to 2x squared minus 3x minus 12. For example number 2, the demand function in Rm for x unit of computer component is given by P of x equal to 320 minus 0.1x. find the revenue function, and hence find the average revenue function. So in this case, we have two questions. The first one is to find the revenue function, and next we have to find the average revenue function. So we know that revenue equal to X times P of X. Okay, so X times P of X is 320 minus 0.1 X. So what we have? Revenue function is 320 X minus 0.1 X squared. So that is the revenue function. And then we have to find the average revenue function. So the average revenue function, R bar of X, is given by R of X divided by X. Okay, so we have 320 X minus 0.1 X squared over X. Okay, so when we simplify, we will get 320 minus 0.1 X. So the average revenue function equal to 320 minus 0.1 X. Now, for example number 3, the revenue function for selling X kilogram of butter cake is given by R of X equal to 30X minus X squared. So we are given R of X, the revenue, equal to 30X minus X squared. The total cost to produce X kilogram of butter cake is given by the cost function C of X equal to 10X plus 20. So we also have the cost function, which is C of X equal to 10X plus 20. Find the demand function and the profit function. So we have two questions here. The first one is to find the demand function, and next we have to find the profit function. So first we find the demand function. So the demand function, how to find the demand function? We know that the revenue R of X is given by X, the quantity, times P of X, the demand function. Therefore, Px will be equal to R of X over X. So Rx equal to 30X minus X squared over X. When we simplify, the demand function Px will be equal to 30 minus X. Okay, so this is the demand function. Okay, and next we have to find the profit function. Okay, so the profit function, pi of X, is given by the revenue minus cost function. So what is our revenue? The revenue is 30X minus X squared, and the cost function is 10X plus 20. So we will get 30X minus X squared minus 10X minus 20. When we simplify, we will get negative X squared plus 20X minus 20. So this is the profit function. For example number 4, the demand for an item produced by Delta Sdn Bhd is given by P plus 0.2x equal to 100, where P is the price per unit and X is the quantity. The total cost C of X of producing X unit of items is given by Cx equal to 800 plus 30x, where X is the level of output. Find, for question A, the total revenue function. So the total revenue function R of X is given by the quantity time price of the product. So what is the price? From P plus 0.2x equal to 100, we get P equal to 100 minus 0.2x. So this is the price function. Okay, so we substitute here x, the quantity, time the price function, 100 minus 0.2x. So the revenue function will be equal to 100x minus 0.2x squared. For question B, the total profit function, so total profit pi of x is given by the revenue Rx minus cost function. So what is our revenue function? The revenue function from question A is 100x minus 0.2x squared minus the cost function 800 plus 30x. Okay, so what do we have here is 100x minus 0.2x squared minus 800 minus 30x. So rearrange, we get negative 0.2x squared plus 70x minus 800 for the profit function. And then for question C, find the total profit when 100 units are sold, means X equal to 100. So when X equal to 100 units, the profit for 100 is negative 0.2 times 100 squared plus 70 times 100 minus 800. So we substitute the value of X by 100. So the total profit when 100 units are sold equal to RM 4,200.